So we've gone through how to solve an equation, even if there's operations on both sides. Now we're going to take a look at something called the distributive property. Okay, and that's going to be kind of our big thing that we're going to look at in this lesson here. And so when a term is multiplied to a set of brackets in a linear equation, the distributive property can be used to solve or simplify for the equation. Okay. Now, the distributive property is something that we've already actually looked at when it came to polynomials and monomials multiplying into the brackets. What we're going to do is we're just going to extend that now to just a number into a set of brackets and then solve. So really we're doing the same thing that we've done in the past, but now we're just looking at it in a bit of a different way, in a bit of a different area. So here's an equation, y equals 5x minus 2. Now the 5 is being multiplied into the brackets, which means that it's being multiplied to both pieces inside the brackets. Okay, just like we did with monomials and polynomials, we need to multiply this 5 into the brackets. So that's something called the distributive property. What the distributive property is we multiply the value, which is also a number, often, okay, which is outside of the brackets, to each term inside the brackets. Right, so we're going to have to multiply this 5 to each term inside the brackets, and we're going to go through that in just a little bit. Then once we have done that, we're going to then collect any like terms, if applicable. So if there are like terms that we need to, we'll collect them together. Okay. In this first case, we're not going to have any, but we will end up having some like terms as well once we go through it. So this one right here, first thing we're going to do is we're going to take this 5 and we're going to multiply it to the x, and we're also going to multiply it to the negative 2. And that's going to result in something different, or an equation that looks a little bit different, and that is okay. So when we do that, okay, I'm going to do it as kind of a side thing right here. We're going to do 5 times x, and again, we've done that in the past, that is 5x. And on the other hand, we're going to do 5 times negative 2, which is negative 10. So once we've done that, then, let's just change the color here, we can actually use these two as our new equation. And so our new equation, or our revamped equation, it's not really new, is 5x minus 10. Now this is a way of getting rid of brackets, okay? And if we can, we try to get rid of our brackets, especially when we're needing to solve this. So this is using the distributive property to simplify. We multiply through the brackets. Now, once the distributive property has been applied, so once we've done the multiplying like we did here, then the value of one variable or the other can be found. Okay? So once we've done this, then we can find the value of the other variable. Now, if we're given x like we are right here, okay, and so we're going to do a couple of these here. So we're going to use this previous equation. We're going to solve for when x equals negative 5. Now, in essence, we could actually solve this one without doing the distributive property, okay? But when it comes, if we're given y, then we really need it, okay? Then it's pretty much mandatory that we use the distributive property. And I'm going to show you why here. Let's say that x is negative 5. I'm going to use the original equation here. I'm going to do y is equal to 5 times negative 5 minus 2. Okay, so all I've done here now is I've plugged in that x value in here, and we can now solve. Negative 5 times negative 5 minus 2 is negative 7. And so we're going to have, and I'm going to show this to you in two different ways. We're going to have, this is going to be negative 7. And then we multiply 5 times negative 7 is negative 35. So our answer is y is equal to negative 35. That's without using the distributive property. If we've used the distributive property, it's actually going to be the exact same thing, okay? Except that we're going to do it in a slightly different way. So now we're going to just take 5 and we're going to multiply it by negative 5. and then we're going to subtract 10 from it. Okay? So we're now using our new formula, which we've created using the distributive property, and to solve it instead of just plugging it into the original. 5 times negative 5 is negative 25 minus 10, and negative 25 minus 10, negative 35, exactly what we got before. So what we can see here is that we have the exact same thing. These are equal to each other. There we go. Okay. Even though we use the different variations of the formula. The first one is the original formula. This one is our distributive property formula. The second one, let's say that we are told that y is negative 2. Now we need to solve for x. It's going to make it a lot easier if we already use the distributive property before we go and solve for x. So y is equal, we already know y is negative 2 is equal to 5x minus 10. In this case here, we now can just solve instead of worrying about brackets in there, which can actually really turn things around a little bit and maybe make it not quite so nice. So using the distributive property makes it a lot nicer. So multiplying through, now we add 10 to both sides. And I'm going to do that using a drawing tool here. So we're going to add 10 to both sides. There we go. And so what we'll get then is negative 2 plus 10 is just 8. And this is equal to 5x, as we've gotten rid of the negative 10. Next step, now we need to divide. So we're going to divide this by 5. And we're going to divide this one by 5. And what you'll notice here is that we're going to have a fraction. That's what this is right here. So what we have is we have 8 over 5 is equal to x. And so x is actually a fraction. We could simplify this, and this is also 1.6. If you do the calculations, 8 divided by 5 is 1.6. We can leave it as a fraction, or if it's a nice decimal, we can leave it, put it into a decimal form as well. Now, if there are terms outside of the brackets, there's my next word here, outside of the brackets. Okay. They need to be added after the distributive property has been applied. Okay, so they need to be added after the distributive property has been applied. So after we've multiplied through the brackets, then we can complete anything that is outside of the brackets. So something like this here, we have y is equal to negative 2 and then x plus 3 in brackets, and then minus 4. What this tells us here is that we have to first apply this negative 2 into the brackets before we can do anything with the negative minus 4. So what we are going to do here is we're going to multiply this negative 2 to the x, and we're going to multiply it to the positive 3. We're not going to do anything to the negative 4. It's outside the brackets. We're just multiplying to what is inside of the brackets there. So what that's going to give us here is that we're going to have that y is equal to negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. That was what was inside of our brackets, and now we just tack that negative 4 on behind. Okay, so tack that negative 4 on behind. Once we have this here, you'll notice that, we'll use the tool here again, these are like terms. Because they're like terms, we can collect them. We can combine them together to create a more unified and simpler equation. Everything else will stay the same. And now we have negative 6 and negative 4, which is negative 10. So our actual equation is y is equal to negative 2x minus 10. And that is our simplified version, or simplified form. Okay. Again, this is isolating y. If we need to isolate x, that's a little bit trickier. It's a little easier if we have y in there, but we're going to do one of those in this case here. We're going to isolate for x. Okay. To isolate for x here, first thing we need to do, apply the distributive property. Solving for x just means to isolate for it. I kind of said that already. So what we're going to do here is, first thing we have to do is multiply everything, or do their distributive property. Okay. Just check here. Okay. All right, so first thing we're going to do is we're going to take this 5 and we're going to multiply it to the y. We're also going to multiply it to the -2. Now we have a second place where we have brackets, and here we have a -4 that we're going to multiply to the x, and we're going to multiply it to the 1. And then this 3 is kind of tacked on at the end. So what this is going to look like here when we multiply everything out is we have 5 times y, which is 5y, and 5 times -2, which is -10. So that's on one side. On the other side, we have -4 times x, which is -4x, and -4 times 1, which is -4, and then we're adding 3. Now, when we have this here, we see that, again, we have like terms on this side, and we want to combine those. We're going to put those together, and we're going to combine them. So right here, these ones are going to be combined together. And so when we do that, we're going to have 5y minus 10. That part still stays the same. And we have -4x, and we have -4 and +3, which means we have -1. All right. So this now is we've used the distributive property, and we've combined our like terms on either side. We want to solve for x in the following equation, which means we need to isolate x all by itself. Now we've got lots of numbers here, but what we want to do is try to move everything from this side onto the other side. And we can do that to start here by adding 1 to both sides. Add 1 there, add 1 here. Okay, these ones are going to cancel out. And on the other side, I'm going to move it up here, or you know what, I might actually have enough room on the bottom here. Let's see if we have enough room on the bottom. Now let's move it up. Little indecision. All right, so what we're going to have here is we're going to have 5y. Now -10 plus 1 is going to be -9. And this is going to equal to -4x. That equals -4x. Now you notice we got rid of that -1. That's good. We wanted to do that. But now we need to get rid of the -4. Okay, and here's where it becomes a little bit different, a little bit, let's call it tricky. Okay, to get rid of this -4, it's being multiplied, so we need to divide by -4. Now we have to divide everything by -4, so we're going to divide this by -4, and we're going to divide this one by -4 as well. Okay, so we have to divide everything by -4. Now it turns out we're going to get some fractions in here, and that's okay. We're okay with fractions. 5 divided by -4 is -4 over 5. So we're going to have 5 over 4, y. So there's a fraction. -9 over -4 is going to be +9 over 4. And that's a simplified fraction. And all this is going to equal to x all by itself. So that is isolating x. Now we could plug in a value for y, and we could solve for x as well. And that would be part of the solution as well. So this is just isolating x, getting it all by itself. It's using a little bit of algebra in solving for x all by itself.